Hello, everybody. Welcome back. We are here to talk about the new interaction design principles, XRI, all these great new things in MRTK3 today. I'm joined with Roger here. I can say a little bit about myself because this is my first talk today. I'm Finn. I joined the team, the MRTK team, about a year ago, but I've been working in XR and other related things since about 2015. I got my start way back when my first app was the VR Museum of Fine Art. I don't know if anybody's ever tried that out, but that's how I got my start. Here on the MRTK team, I've worked on a lot of different things. I actually interned with this team and I helped out with MRTK V2. I've been using MRTK and Holo Toolkit for a long time as part of the Windows Mixed Reality like student outreach program, which was really fun. But on MRTK3, I primarily work on hand tracking, interactions, UI, all that good stuff.
Hey, I'm Roger. I also work on the MRTK team as an engineer. On MRTK2, worked a lot on our Oculus Quest platform support, and on MRTK3, it's a lot of the similar things. We're trying to make sure that MRTK works on every platform to the best of its ability. So Quest, HoloLens, and lots of WMR things. No exciting tidbits about VR museums of arts or other sorts of things, but um, anyone can join in the space.
So today we're going to be talking about some of the new types of interactions that are going to be available in MRTK3, especially because of the choices that we've made surrounding XR Interaction Toolkit, which you've heard about in previous talks, as well as some of the new features that we're bringing to the table, including our UI, interactables, manipulations, and all that good stuff. So I'm sure a lot of you in the audience are very familiar with MRTK v2 in terms of how input and interaction was set up, right? So you had these input profiles, you had our monolithic focus provider, you had to do your controller mappings, you had all of these visuals that were really tightly coupled with the input and interaction. So in MRTK3, we've tried to take a step back and took a closer look at how we might be able to streamline, simplify a lot of this stuff, and take advantage of all the great work that's been done on the Unity side with the XR Interaction Toolkit. So like input profiles, right? Like we don't really need them anymore because XRI handles a lot of what we used to do in terms of cross-platform interaction. We don't need a focus provider of our own anymore, and XR Interaction Toolkit actually does a lot of what our focus provider stuff used to do. The focus provider was really monolithic. It had a lot of bugs sometimes. It had a lot of performance challenges for us. And it turns out that the XR Interaction Toolkit has done a really good job at doing a lot of what we had to do with our focus provider. The Unity input system also handles a lot of what we used to had to do for controller mapping and mapping buttons and whatnot. That's all handled on the Unity side now. We don't even need to worry about any of that. And another really big thing is that the visual side of the interactions are just completely isolated and separated now. So both on the input and interaction side and on the interactables. So in MRTK v2, a lot of the things like your pointers and whatnot were very tightly coupled with the visual representation. And the same thing with your interactables and your buttons. The interactions and the visuals that were associated with those were very tangled. And so we can solve a lot of these problems with the XR Interaction Toolkit, which Roger can talk more about.
Yeah, so what the XR Interaction Toolkit, it is basically a framework built up by Unity itself. It offers a lot of the fundamental things which are crucial to driving interactions in the XR space. So the main thing we're trying to get is that a lot of the old things that were very hard to do at relatively low level, such as handling how your controller buttons map to various controls, how when you put your hand next to a button, the button would actually compress. All of that stuff has been offloaded from the MRTK side of things, and now it's all incorporated inside Unity's XR Interaction Toolkit. So funny thing about this is that when they were building it up and we were talking to them like, hey, how's this thing going to look? Like, how can we use it? It turns out a lot of the core principles of the Interaction Toolkit were influenced heavily by MRTK2's interaction design. And that conversation picked up. We've developed a good collaborative story with them. And now it is out there in the public. It is still being updated and maintained with collaboration and input from us. But the important thing is all of the hard stuff, all of the, in the future a new controller gets released, how exactly does that get read and mapped? That's all handled by Unity, and that lets MRTK focus on what it does best.
The thing I want to call out is that we've actually been in meetings with the XR Interaction Toolkit folks like every other week. A lot of what they've built and what they've changed in XRI has been directly inspired by the feedback that we've been giving them. So it's been a really collaborative process, which is really exciting because being able to influence the direction of this Unity work has been really exciting. And so like XRI, it's really performant, which is awesome. It's really, really elegant. It's really, really tiny and simple. It's honestly one of the nicest Unity APIs I've ever worked with. And I like Unity has a wide range of quality when it comes to their APIs, of course, but I think XRI is a really good one. We've never run into something in XRI that we haven't been able to work around or extend in a really intuitive way. The other really cool thing is that it's becoming this interaction standard between applications. So one of the big things is that we know that there's already applications out there in the wild that are being built on the XR Interaction Toolkit. I don't know if you've heard, but Snapdragon Spaces is actually using the XR Interaction Toolkit as their interaction layer. And so because Unity is offering this simple abstracted interaction layer, a lot of different people are starting to agree on what these interactions look like. And to accomplish this, it's really, really flexible and really, really extensible. But like Roger said, right, the most important part of all of this is the basics Unity can take care of. And we can focus on what we do best, which is building these really, really juicy, cool interactions and UI and building blocks for you guys to use. What exactly is XRI under the hood? So there's this kind of a distinction between the interaction system, right, and the input system, because we're using the Unity input system for our input, which means actually getting things like the positions of the controllers or the hands or where your hand joints are or where your head is, right? That's the input system side. And that also handles things like, what's the grip action, the click action, the trigger, whatever, But the interaction system is a many-to-many mapping between a set of interactors and interactables, right? And so you can have as many interactors as you want, right? And these are kind of the analogy to pointers from MRTK v2 in a way, but you can have as many of them as you want, and they can just be on anything. They don't even have to be driven from user input. They're just this abstract object that can perform interactions in the scene, and that's it. And it's a many-to-many mapping, of course, so you can have multiple interactors interacting with one interactable. You can have one interactor interacting with multiple interactables. It goes back and forth, which is really, really nice and really flexible. Like I said before, some interactors are driven from controllers. So in XRI terms, a controller is something that binds to an input action, basically. So this includes something like your hand or a motion controller or even your head. Your head is actually an XR controller. So for example, our hands, right, we have some interactors that are driven from your XR controllers on your hands. Other interactors don't have to be driven by user input, which is really cool. So something like, a stylus or a pen or like a robot arm that can be moved around to grab things, right? That is just as much of an interactor as the one that's on your hand. There's this really interesting and nice disconnect between the idea of what the user input is and where the interactors are. So for example, like with this stylus, right? There's nothing going on with user input here. That poke interactor is literally just on a physics object. Like you could throw this pen at a button and it will click the button, which is pretty funny.
Yeah, we've talked a lot about the interactors, right? But obviously, what's the point of me having a module that can interact with things if there's nothing to interact with? And that's where XRI defines the mirror of this two-sided relationship, the interactables. And the thing we've done in MRTK v3 is that we've made it our goal to keep the interaction state, so all the interactable state stuff, separate from the visual itself. In MRTK v2, some of this got a little bit intertwined, but because of XRI's defined API for how you have an interactor interact with an interactable, being able to keep these things completely separate. So your visuals, they sit on top of the interactable. They listen to this underlying state of the interactable and will respond accordingly. So when your button is selected, the button will compress. You no longer have to have that implicit worry of, oh, okay, I have to actually press down on this button in order to get the state to, switch off. You can switch the state off, and then we're going to have the visual conform to that.
As a concrete example, like all of these interactables are the exact same interactable. There's no difference. So like our nice fancy juicy UI buttons up there, those blocky custom buttons like a piano keyboard, it's exactly the same interactable and interaction code underneath. There's absolutely no difference. We have just some different visual layer that listens to the interaction state, and it just looks different. And that's really nice because you have this really clear separation, and it becomes way more maintainable and much less spaghetti.
Yeah, and as we said before, right, all of the things in XRI, it's built with multi-selection in mind. So all of your interactables, they're going to be multi-hand by default. You can have one hand, two hand, up to like any number of things trying to interact with the same thing, and the logic underneath it will end up working out the same. We'll be covering a little bit later exactly how that works, but if you want to have two fingers pressing a button and then one finger half presses, one finger fully presses, there's not going to be any sort of who entered first kind of state sync. It's just button is pressed, the button is pressed. And this all may sound pretty complicated, right? But don't worry, XRI has great tooling in order to make sure that you can debug any sorts of issues. One of the best things we've used is this XR interaction debugger, and what happens there is that it'll list, here's all the interactors you have in the scene, here's all the interactables you have in the scene, what's interacting with what state are all these interactables in. It's in this very nice, well laid out tool, visual representation. And this is something that is really beneficial as far as like how it helps us on our development, because before in MRTK v2, we would have to have made this tool ourselves. We would have to update this tool ourselves whenever we added a new interactor or an interactable. And it just got, it would be something that we would show, we'd be like, this is great, but inevitably it would start to become a lot more maintenance for us for every sort of additional feature we added in. And being able to hand off this multiplicative cost to Unity, who has a much better idea of what they need to do here and has a much smaller scope as far as like what things they are explicitly going to support, and then letting other developers extend off that is a really big boon for us, and we believe for the rest of the XR developer community.
So the rig obviously is an important part of this whole setup, but the rig in MRTK3 looks quite a bit different than the rig that you might be used to in MRTK v2. It's essentially identical to the XRI rig setup, but there is a few other things that I wanted to call out here. So this slide is called the do-it-yourself rig for a reason. Almost everything you see here is completely optional. And the idea is that all of these things are basically WYSIWYG, what you see is what you get in terms of where things are in the hierarchy. So you can build your own rig. There's nothing special or magical about our rig. It's just a good starting point for you guys. And you can customize it. You can add your own interactors, your own controllers. You can do whatever you want to it. But the idea is that there's nothing magic about it. Things don't magically appear from some configuration somewhere. It's just you see the interactors, and the interactors are there, and that's just about it. The only actually 100% required part of this whole machine is the XR Interaction Manager. So that's the brains of XRI. That's that many-to-many mapping that I was talking about before. That's what is actually necessary to get all of the interactors and interactables lit up. Yeah. But
I just wanted to follow up on that. So we've mentioned this rig, you could add whatever you want to it, but this also means you can take away whatever you want. Yes. So if you're looking at our controllers or interactors, you're saying, I don't need this. I don't have a right hand for whatever sort of interaction I'm trying to do. You can just axe it, disable the game object, delete the game object. Nothing will break.
Yeah, exactly. And so you can see here, we have some interactors that are set up on the controllers, like I was talking about before. Some interactors are driven by controllers. So, you have your right-hand controller here, and you have, your poke interactor, and your ray, and your grab, and your gaze pinch, and all that. But some interactors don't have a controller, right? So, like that MRTK speech interactor down at the bottom there, that's our speech interactor. That performs all the interactions when you have some keyword that you say and it like clicks on a button or whatnot. But that's not driven by a controller. And then some interactors aren't even on the rig. So that canvas proxy interactor, for instance, That isn't even on the rig. It doesn't have to be. In fact, none of these interactors actually have to be part of the rig. In addition, right, you can add things like AR Foundation to your rig and it just works, which is pretty cool. The other cool thing is locomotion, right? So XRI ships with some great locomotion systems out of the box, right? So you can actually just add like a character controller and the XRI locomotion providers to this, and it doesn't actually need any MRTK code to work. It just does what you would expect. So as an example as to how exactly streamlined this stuff is, I just wanted to do a quick demo of how you would build a brand new custom interactor, because that's something that we've seen a lot of people do. You know, you have some new device, there's new interaction, right? And you want to build some fancy new interactor, right? Well, how hard is that, right? It's really not. That's it. There's not actually even any MRTK code involved in making a custom interactor. It's completely just XRI. Literally the only thing you need to do is just say, oh, what are my targets? And that's it. And then the key to this, right, is back in MRTK v2, right, if you built a new type of pointer or whatnot, it wouldn't necessarily work with our existing like interactables, right? So say you had some kind of new interaction and you know, it manipulated objects in some interesting way, right? Our object manipulator, for instance, didn't know that your pointer existed. It didn't know how to deal with that. So this pattern allows your brand new interactor actually to already work with all of our existing interactables, which is pretty cool. And we'll talk a little bit more about how that works. But this whole system is built to be future compatible in the way that you can build new interactions, and every single one of our existing interactables will work out of the box with it. Even complicated interactions like dragging and manipulating and moving.
Yeah, so we've talked a lot about like how easy it is to build new things on top of XRI, but what new things are we building on top of? Here on this little word cloud, we've introduced basically a handful of new interactors and interactables that we've built for MRTK on top of XRI. So under the interactors, you're going to see some things, you know, you kind of expect are kind of typical. They may have existed in V2 even. So, you know, grabbing, poking, those all existed in V2 via some form of our pointers. Speech existed in V2, but we also have some new ways to interact with objects, such as using gaze. It's going to be a lot more developed, I'm sure, as you may have seen with the Zappy Playground demo, as well as gaze pinch, where you can look at an object and then pinch over to the side, and you would be able to essentially select the object using your eyes. Other new interactors that we've created is interactors that have an idea of variable selectedness. So you can do a half pinch, kind of like a half button press. And you know, that sort of rich interaction is something that we really wanted to take advantage of in the XR space, just because of how analog, you know, interacting things with your hands or like, you know, with your body movements ends up being. On an interactable side, you know, we have some classics. We got the object manipulator, everyone's favorite, sliders, but also some new things like a whiteboard and pressable buttons, which, though they existed in V2, they're not as used as they are now. They're all built on top of this thing called Stateful Interactable, which, as we've said before, is kind of the underlying driving component that'll let us be future-proof to, you know, maybe new ways of how you want to interact with things.
So all of these awesome new interactors and interactables that Roger just talked about, like how would one of the interactables like know how to deal with one of the new interactors, right? This becomes an even bigger question when you realize that not all of these interactors and interactables are even in the same packages. They're completely spread across a whole bunch of different packages, different assemblies. They don't even know that each other exists necessarily. You might build new interactors, or you might build new interactables that we have no idea about, right? How exactly do we have our interactables understand how to deal with your interactor, right? So like how does a whiteboard, right, which is not even in the same package as a poke interactor, know how to deal with a poke interactor? How does a pressable button understand how to deal with gaze pinch? Because if you look in the pressable button code, there's not a single mention of gaze pinch anywhere in it at all. How does it know how to deal with a gaze pinch interaction? How does object manipulator know about a brand new interactor that you build? You might build an interactor that does some crazy, I don't know, lasso whip interaction. I don't care. How does object manipulator know how to be manipulated by your new interactor? this all kind of boils down to, like, how can you build and prototype and deploy new styles of interaction without having to go back and rebuild all of your interactables? And the secret is the interactables just don't care. Things like object manipulators, buttons, etc., they actually don't care about what kind of interactable, what kind of interactor is selecting them. In fact, in our documentation, we actually recommend people not use like the interactor specific events. So like we do have events where you can be like, oh, I want to fire an event when I get gazed at or poked or grabbed, right? We actually recommend people don't care, because people might build brand new interactors, right? And we may not know about them. And so you can build your interactables to be completely like interactor agnostic, basically. In some very, very, very limited cases, we do still care. But in those cases, we use interfaces. So you can still build custom interactors that will behave correctly. So Roger can tell you a little bit more about some of the infrastructure that allows this to happen.
Yeah, so how exactly does this happen? Okay, we've said a lot of things. It sounds all very magical, like everything will just work. Well, the key to the secret sauce is that XRI has defined a very robust and common set of interaction events. So what you'll have here is you have hover, which is when is your interactor considered to be ready to select over an object, taking into like a it's if your hand is close to an object, you might say, okay, you're ready to pinch. Or if we want to think in like our traditional known context, like web, it's when your mouse is hovering over a button. After that, you may be selecting the object. So, that's your mouse click, that's your pinch. And then after that, there's an extra event that XRI has built, which is called activate. So you're selecting an object, maybe you need to trigger something else to fire another event. So let's say you're grabbing an object, you use scroll wheel, something like that, anything like that. It's all up to you guys, and it's all just kind of built into XRI. And this common framework is what allows a lot of our interactors to kind of interface with each other and respect basically, hey, I don't care who's interacting with me. Me, the interactable, will know how to respond appropriately. And all this is built to be compatible with multi-selection. So there's whatever you hovered on something first, whenever the thing that hovered exits last. Like all of this allows you to basically have multiple things work and interact with the same object. And this is very important for the XR space because traditional 2D spaces, you have one finger touching a screen, one mouse hovering over a button. But in XR, you're going to have multiple things going on. You have two hands, you have your eye, you have your head. There's so many things there's so many ways you can interact with something, just like there's so many ways we can interact with something in the real world. And all of this is built on, this was all built with that in mind. So these common sets of XRI events.
Yeah, the example I always like to use is you can have a poke interactor on every single finger of your hand, and you can use every single finger to simultaneously press the same button, and it will actually respect it correctly, which is really funny. But it just goes to show that none of this ever assumes at any point in time that there's only one interaction happening, and you can mix and match interactors too. So you can be poking a button and then ray clicking the button and then gaze pinching the button, and it just deals with it. And the exact same code paths and the exact same events fire. But then, right, so Roger said, right, there's these set of common events that get fired, like hovers and selects. But what about more advanced interactions like manipulation, right? Like we were talking about object manipulator, where how does it know how to be manipulated by your brand new interactor? And the answer, again, comes from XRI, which is this concept of something called the attach transform. I like to call it the universal point of manipulation, because it's an abstract anchor point that can be used for anything, really. On a ray, for instance, the attach transform is the point at which the ray impacts the object. When you're grabbing something, it's the point on the object where the user actually initiates the grab. On a poke, it's the center of that poking finger joint. We also expose a poke radius as well. A gaze pinch, it's a bit more complicated. The interactor computes this interesting offset by the centroid of the pinch, but it's still just an attach transform. And from the perspective of the interactable, it doesn't care. It can treat every single one of these attached transforms absolutely identically, and it will just work. So in this way, you can do things like Like this is an example of something that just straight up did not work in MRTK v2. In an object manipulator, you can mix and match the different interactors that you're using to manipulate an object. You could grab it, you could do a near grab with one hand and then ray grab it with the other hand, and that is still a valid multi-handed interaction. You can gaze pinch it with one hand and near grab it with the other. It doesn't matter because the interactable, again, just doesn't care. It's just an attached transform. All it knows is there's some interaction happening and its pivot is at this point.
It's basically been like, it's basically a abstraction of, where is this interaction position? Where am I interacting with this thing? And this is defined all on the developer end. You can make it whatever you want. And that sort of freedom lets you lets you separate, okay, what is my interactor in the game world, in the physical space, from, okay, how does this thing actually going to interact and manipulate this object?
Yeah, and so the concrete outcome of this, right, is that in MRTK v2, when you looked at things like object manipulator, there was a whole bunch of logic and math going on the object manipulator side. The object manipulator would be like, hey, are you array? If so, let me do all this crazy math to figure out how to be manipulated by array. Oh, you're a near grab. Oh, let's do this other kind of math to figure out how to be manipulated by a near grab, right? And it's just this completely separate code path. So in MRTK3, all of that logic is just on the interactor side. So the interactor does all of the complicated math to figure out where its attached transform is supposed to be. And then the object manipulator is just like, oh, there's the attached transform. Let me just attach to it. And that's it. So what do we get out of this compatibility? Because we've been talking a lot about this idea of, oh, you build a new interactor, right? And it just works with ours, or our interactables just work with yours. XRI is it already exists. People already build things with it. And so obviously there's a set of interactors that are shipped with XRI, right? And there's a set of interactables that are shipped with XRI, and those obviously talk to each other just fine. We also ship, our MRTK interactors and our MRTK interactables, and those obviously work together just fine. The cool thing happens when you mix them. So because of the modular packaging scheme of MRTK, you can actually bring in just our button or just our object manipulator to an existing XRI environment, and they'll work. So if you only care about, say, our buttons, you can just take our buttons and you can bring it into a completely unrelated XRI project, and it just works. So packages are hard. And Roger can talk about this whole variable selection thing.
Yeah. So up to this point, we've talked a lot about how things are the same, right? How can you still do the good stuff in MRTK2? How is it going to be easier to do that good stuff in MRTK2? But let's get into the exciting stuff. What's new? What's exciting? And what we have here is one of our first highlightable features is variable selectedness. So imagine you have a game controller, right? Most of the buttons on the controller, they're digital. You press the button, it's either up or it's down. But there are two buttons on the controller, the triggers, which are a little bit analog, right? You can half squeeze them, you can full squeeze them. And that's just for controllers. Obviously, there's a very limited fixed set of buttons. And not everything has to be built with that in mind. In XR, your hands are your controllers, generally speaking. And these have a super wide range of analog movement. So when you're trying to grab something, you can grip it lightly, grip it tightly. When you're doing a pinch gesture, you can half pinch, partially pinch. And all of this stuff falls under this bucket of what we like to call variable selection. And so what we've built into MRTK3, and along with our collaboration with the Unity team, built into XRI as well, is this concept of selectedness. And this is something that's built into each one of our interactors. So for the ray interactor, it's obviously a partial, how much you're pinching. For object manipulator, it's the same thing with grabbing. But even for something like poking, right? So let's say you're poking a button. You don't have a, let's say you're poking a button. That button doesn't necessarily have to be pressed all the way right when you touch it, right? And what we've done with our new set of MRTK3 UI is build in this idea of selecting this into that button as well. So when your poke interactor gets close to the button, you can press it slightly. But not only that, when you're looking at it from far away and using a far array pinch, when you half pinch with your hand, that'll half press the button as well. So the idea is that this underlying idea of selectedness has been kind of baked into our UI, and we're kind of making it one of their first principles as far as how we want to make super immersive great XR UI. So how does variable selection work? Well, so you have multiple, so we've talked about how everything is built with multi-selection in mind, right? Let's say you have a far-away interactor trying to pinch a button, and you have your poke interactor trying to pinch a button. What ends up coming out on top, right? How do you know how pinched you should be? And we basically have a max function over, all your non-variable interactors and your variable interactors, and whichever one comes out on top, that ends up being the ultimate selectedness value for this piece of UI. It's a monotonic function for anyone who is super into that. So it's built into our pressable button. As you see here, the same code is there, just the max of the base of the underlying variable and non-variable max, as well as the max of the pressedness. So this comes into play. Let's say you have a third piece of UI, right? It's just a mouse click, right? And a mouse click doesn't have an analog input. It's just either down or up. And by taking the max over literally all these selectedness values, we can create a consistent experience no matter how you're interacting with an object. So if you're half poking, but then mouse decides to click, the button will snap and be like, OK, I'm actually fully poked now. But when the mouse releases and you're still half poked on the button, just like in real life, the button will pop out slightly, hit your finger, and then be like, OK, this is how selected it is, and whatnot. So 3D, pushing, pinching, grabbing, all basically work equally and are treated equal on the interactor side of things.
Yeah, the benefit of this, right, is that you can, drive your pressing animation, your squeezing animation, or whatever, just from this abstract concept of variable selectedness. And regardless if you're doing an air pinch thing or a ray trigger, right, all of these variable selection, modes all feed into the same number. So you don't have to build custom animations for like, oh, this is what happens when you half pinch versus half press versus whatever. It's all unified, which is really nice. And then we also have some debounce thresholds for this, right? So obviously, if you have this, gradient of selection, you don't want to have just a single threshold for when we consider things selected, because then, you've, halfway pressed your button, and then all of a sudden it's, flickering on and off. So all stateful interactables that have this idea of variable selection have this nice debounce threshold, so your interactions are consistent and reliable.
Yeah, we want to emphasize that, XR space, there's a lot more variable kinds of input, so we want to make sure that all of our UI can handle variable kinds of selection as well.
Yeah, and then Roger will walk us through what interaction modes are.
Yeah. So we've talked about selection, but the other thing to consider that's very unique in XR, in the XR space is basically how fuzzy the different contexts of how you interact with something is. So, like, let's say you're in this room, like you're looking at a chair, and then you as the program, you have to ask, okay, is the user trying to gaze select this chair? You move your hand near a button. It's like, okay, are they trying to poke the button? And what sorts of UI should pop up? Like, what sorts of ways of selection should be valid at this point, right? Obviously, if my hand is red about to poke the button, you don't want your program to suddenly, like, as you kind of half pinch, say, oh no, you're looking at that microphone. I'm going to grab the microphone. It's a very unintuitive, it can create very jarring experiences, and this space is extremely fluid and hard to navigate just, conceptually. You don't want to write a bunch of rules. It's, definitely a pain. And we had something like this in V2, where it was something called a pointer mediator, right? It was a very simple bare bones one. It would be like, okay, look, your hand is near an object. You're in near interaction mode. Your hand is far away from an object. It's far interaction mode. In MRTK3, we built this out to a much more robust way. We have, instead of defining, just you're either near mode or far mode, we've defined an abstract list of interaction modes. And so we'll start with how this first works off, right? So you have your XR controllers. Each of these represents an input source. And each controller will have some set of interactors associated with it in general. And this is an important thing for navigating its interaction mode space, right? Because in traditional context, as we said before, right, you usually only have one way of controlling and interacting with the scene. In XR, you have two hands, typically heads, and if one hand is in near interaction mode, maybe you still want the other hand to be able to select things with far interaction. So first thing we've done is that we've bucketed all of your interactors according to controllers, and then each controller will be able to be in a different mode.
And this is all automatic. You don't have to configure this yourself. This scans your rig and organizes and buckets all of your interactors so that you can associate them with particular modes.
Mm-hmm. Yeah. So once you have all the modes kind of bucketed, right, now it becomes a question of, okay, how do you know which ones to enable or disable? And the way we've had this is that in our UI, we have a interaction mode manager, which lets you define each interaction mode, and within each interaction mode, which interactors are available. So this is, again, going back into the case of, you're near an object, like, okay, when I'm near an object, I want my far raise to be off, I want my gaze pinch to be off, etc. That's just a crystallization of that idea, more or less. Yeah, exactly that. The far raise there, you're near, okay, far raise off. That helps a lot with preventing accidental presses and whatnot, but it goes a little bit farther, right? Let's say you're trying to grab an object. Well, if you're grabbing an object, you obviously don't want to poke an object too. And creating modes for far raise select, gaze select, our interaction mode manager lets you specify up to that level of granularity as well. And this, it's all in the service of making it so that when you're navigating your scene and trying to interact with things, anything inadvertent, anything that's confusing the user is mitigated as much as possible. You can even have, on one controller, if you really want to, turn off interactors on another controller. Let's say you wanted to say, okay, everything in the scene is now going to be in near mode. That's very possible. And how is it possible? Well, we have these things called interaction mode detectors. So one of the more, as you can see here, right, the hand, as it hovers over the object, it turns into near ray hover mode. As it gets near the cup, it turns into near mode. And this is all driven, it can be driven by literally anything. The near detection is driven basically by a sphere collider that says, okay, is my hand near any other interactables? Things like going from far array to far right hover, that's just on the script itself. When the script says, okay, I am now hovering an object, it says, okay, I'm also going to switch my controller into this far right hover mode. So anything you can think of, any way you might want to control or help guide the user into what is the right way to interact with an object, that's all very doable with our new interaction mode manager. If you have two detectors that are trying to report at once, okay, I want you to be in far mode, the other one says I want to be in near mode, our interaction mode list is all neatly ordered, and whichever one has the highest priority ends up taking control. So it's just more ways of helping you define, resolving any confusion as to okay, what is the user actually trying to do? What is their intention? And as a developer, how do I want the user to be able to confidently navigate through my space?
And a lot of these options for when certain things should be on and when they should be off are actually kind of a matter of opinion, and when whatever you see in your user research and testing. So even internally at Microsoft, we've had some teams that are oh, we actually would prefer this interactor to be on or off in this particular context, and they can just do that because they don't have to write any code. They can just go in and they can change the priority of a mode, or change where the detector is, or change which interactors are associated with a particular mode, which is really nice. So I'm going to take you on a little tour of what exactly all of this crazy stuff means for something like our trusty old button. So a few interesting options, right? So some of this might be familiar to you from MRTK v2. We have these configurable press planes, right? So you can see, here we go. So you can configure, right, the start push plane and the end push plane. You can drag them around. That's the same as it was in v2. But in MRTK3, right, these now map to that whole idea of variable selection, right? So the start press plane, right, that is where that zero selectedness is defined. And the end push plane is where the one selectedness is defined. We also have a bunch of way more powerful heuristics and options for rejecting false input, as well as detecting roll off and when a user wants to cancel an interaction. Because when people first select a button, right, there's a lot of times when they want to cancel, right, and that's a weird concept because in 2D land, right, you can just click on something, but then usually when you roll off the button with your mouse cursor, it cancels the interaction. But how do you do that in 3D? How do you do that with gaze? Or something like a gaze pinch, right? That's weird, right? So we have a bunch of options for roll off, especially in terms of the 3D poke roll off. So we have options for you can't push a button from the side. You can only enter the button from the top. If your finger drifts to the side too much as it goes through the button, we can reject the push. It's really powerful because we really Hand tracking isn't always perfect, right? And so there's a lot of erroneous input sometimes, and so having powerful roll-off options is really nice. And like we've been saying this whole time, with the multiple selection, you can do these really cool things like, ray click a button and poke it at the same time, and you release the ray and it like snaps up and just hits your finger, and it all makes sense, which is really cool. It's very physical. It's very immersive. So what does a typical like poke interaction look like on one of our buttons? So something unique about the poke interactor, right, is that it is just always trying to select everything. That's how the poke interactor works. So on other types of interactors, right, it's driven from like an XR controller, right, where there's like a trigger or some kind of select or grip action that fires the selection, right? So, and in those cases, right, the select active property in XRI is driven from like the button or whatever, or like the trigger controller or whatever. But if for poking, right, there is no action to initiate a poke. It's just whatever your finger is on, it should probably be poking. So in XRI, in our setup, poke interactors are just always selecting. It's up to the interactable to be like, oh, no. You haven't poked me enough to be a selection, and so I'm going to reject your selection. And so XRI has this great little check called is selectable by. And so the way that we do this is basically if it's a poke interactor, right, the button will look at the poke interactor's attach transform and be like, oh, have you pushed me enough? Is my front plate depressed enough to be considered a valid push? And if so, then yes, you can select me. And that allows the selection to go through, and the button is then selected in XRI. And of course, right, you can have any number of these poke interactors participating with this button, and so you end up with a max function of the pressedness of all of these interactors. And then, so what does this look like in terms of the interaction states? So we haven't talked about state visualizer yet. That's something that I'll be talking about in my later talk within the UI systems. But just for now, you can think of it just as a nice way to show which states are actually active right now. But so, for example, when your finger is near the button, right, that's considered a hover. It hasn't actually started pressing the button yet. But as you can see, the select state is not active, but we have hover states active, and our selectedness is 0. Then, as our finger enters the button and slowly begins to depress it, we can see that our select value, our select state is now at 0.6. So we're 60% of the way through the button. We're still hovering it, obviously. And then when our finger has reached the end, we are now fully selected. The interesting thing, right, is for things like the button press, right, that is just driven directly from this number. So in State Visualizer, I'll talk about it later, it can drive an animation from this. But the idea is that the button itself doesn't have a concept of, oh, go move the front plate, go move the visual. The visual is completely isolated. It's just, oh, I'm 80% pressed. And then it's up to, whatever visuals you want to actually illustrate what that even means. But as you know, you can do other things to buttons. You don't have to just push them. You can gaze pinch them, for instance. So the gaze pinch system works works in a pretty interesting way. So it actually is sort of like a cooperation between two separate interactors. You have the gaze pinch interactor, which sits on your hand because it's a pinch. But obviously, you also have the gaze interactor. And so when the gaze pinch interactor is being asked, hey, what are your targets? It just goes and asks the gaze interactor, hey, what are your targets? And then it just uses those targets. But so how do you do this whole thing where, right, I'm halfway pinched? The way this works is we have an interface called a variable select interactor, and your own interactors can implement this interface. It's really tiny. It's just a select progress property. But in stateful interactable, right, the selectedness of the button is just the max of all of the select progresses of each individual variable select interactor. So, right, your gaze pinch interactors, which are variable selection because of the pinch, but your ray interactor is also a variable select interactor because of the analog trigger or because of the air tap. So this looks very similar, but you're gazing at the button, right? And so we have a passive hover state that becomes active. Passive hover just means an interactor is hovering it, but that interactor doesn't intend on selecting you. So, for example, the gaze interactor alone doesn't select anything, so that's considered a passive hover. Then when you bring your hand up to the ready position, the gaze pinch interactor then initiates a hover, and that's considered an active hover. So now we have both hover states active. But you notice we still don't have any selectedness going on. So then I don't have a nice animation of it actually pinching, but I'll just take my word for it. You pinch halfway, and because it's a variable select interactor, the interactable is like, oh, okay, I'm 50% selected, and that will progress to 1 just like it does for the poke. And it's the exact same code path, the exact same animation. There's nothing bespoke for something like a gaze pinch versus a actual poke. So I hope you have enjoyed this deep dive into how interactions and interactors and interactables work. We have a little bit of time for questions, if anybody has any questions.
No questions. We did a great job. All right. No one?
Thank you.
Thank you so much.
Oh,
we have someone over there.
Yeah, sure, right there. Oh, I guess we're gonna go to him first. Okay, sorry.
That's the one I saw. We'll get you next time.
Hey, how's it going? Thanks for the presentation.
Yeah.
So super cool to see the design of this is, both from the user experience of actually interacting with all this, things like the roll-off. Clearly, lots of thoughtful design. Are there plans, or what are the plans to roll developments like this into some of Microsoft's first-party either applications or like the holographic operating system? Because some of the base interactions don't work as thoughtfully, buttons on just selecting apps or live cubes or things like that. Are there plans to take learnings from MRTK3 updates into the holographic operating system?
I can't talk about anything involving the shell or the platform, unfortunately, but I can say that because we've been working on this stuff for so long, a huge number of teams inside Microsoft working on other internal products are directly using this stuff. And so future first-party products that may or may not be coming out in the future that I can't talk about, they are all using MRTK3 as a first-class citizen to power their all of their interactions and their pressing and their poking and everything. So yes. And then,
We have one more over there.
But yes, thank you. Very good question. I also wished that the holographic shell was as juicy as this.
Yeah, thanks. Very interesting presentation. Thanks for that. I was wondering, modeling all the gestures that you guys are describing and all the interactors could be a really complex challenge for us as developers. I was wondering if you guys perform any kind of usability tests or user experience tests prior to deliver this solution? And if so, would you mind to share some details on how you do that?
You're talking about like user experience, like the developer experience, or the end user experience?
End user experience.
End user experience, yes.
Yeah.
So we have a large dedicated team of interaction design researchers here at Microsoft. We work with them on a day-to-day basis. For example, like the biggest thing, like that gaze pinch work, that came directly from an internal prototype that the interaction design team did, which was the product of tons of user research and testing. You can see an early version of that gaze pinch in the Mesh app for HoloLens today, but all of that is all is all a product of a whole bunch of really intensive user testing. So yes, we absolutely do talk to users and test this stuff to make sure it works well.
And we're still iterating and updating it all the time. Over the past few months, we've gone from a rougher version of the gaze pinch, where it was hard to target more clustered sets of objects, into one that has become more refined, and without even that many more performance impacts as well. So anyone who is concerned about, hey, how does this, maybe the interaction is slightly better, but all the performance is a lot worse, even that's being taken into consideration as we, iterate and collaborate closely with our design and UX research teams.
And when those user researchers are working and prototyping these things now, they're using MRTK3 internally. So because they are still evolving things like gaze pinch and gaze input and just everything in general. And so when they feel that some new design of theirs is ready for prime time, it'll be a lot easier to just bring it into MRTK3 for all of you guys to enjoy. Any other questions? Anybody? Nope. Okay. Thank you very much. We really appreciate your time. I hope this excites you as much as it excites me. And yeah, thanks for listening.